Franceschi from Italy, and I'm here to talk about Puppet modules and an approach I tried to develop Puppet modules. I work on my own in a company called Lab 42. I'm using Puppet for various months, years. And in the course of the years, I've tried to develop modules with the intent to be reusable. So I wanted other people to use these modules. And I tried several times to do modules with different patterns. So in the course of the years, I wrote, let's say, different generations of modules with more or less different layout, which were somehow also related to the current version of Puppet, which was available at the time. Now I'm going to present this next generation of Puppet modules. Well, it's next generation for me. I don't know if it's a real, if I can apply it to everybody. And I hope you will see something interesting also as ideas on how to do something with modules. So, I suppose we are here because we really use or love Puppet, or we are going to use it. And if you are going to use it, you will probably love it. Currently, people use Puppet for, of course, configuration of the systems, most of the times monitoring of the systems, which is most of the times automatic, of course. We can use it as an inventory based on the effects we can have from the nodes. We can at times use Puppet to manage the deployment of applications or to, let's say, manage the environment to deploy in some way the applications. And we can use Puppet and mcollective to orchestrate operations in our infrastructure. Now, I would like to, let's say, extend, not in the Microsoft way of extending, but to use Puppet also to some other things. My idea is that since Puppet has so much knowledge about the system, because it configures it, I think that it could be used also to provide more tools to cope with the system. So, for example, all the knowledge that Puppet has about the system configuration files, where they are located, the name of the packages, name of the services, can be used in command lines to quickly retrieve information about the system itself. And also to, let's say, have a sort of enriched inventory, because one thing is what you can get from facts. Another thing is what you can get from commands that run according to the configurations you have in Puppet and give you detailed information about what's installed on a system. Also, Puppet can be used to monitoring stuff, but my personal point of view is that in our modules, we should not specify what to use to monitoring what is provided by the module, but we should define what the resources that the module provides, and so what to monitor, without caring directly in the module on how to monitor those resources. So that's what I call abstracting the monitoring in Puppet. Also, I use Puppet to automatically configure host-based firewalling. And the general idea is also in my modules to try to have a sort of a coherent infrastructure of modules, internally coherent at least, where you can be sure that some variables, some parameters you pass to classes and so on are always the same on your modules. So you have a sort of coherent and integrated infrastructure. So, in the Puppet module community, there have been many discussions about what could be the right way to do things, the best practices, and the perfect module, as someone would say. Actually, there is not agreement on that, of course, because actually, since Puppet is a language, you can do with Puppet is also a language. You can do with Puppet things in different ways. So there is probably not the right way to do things, but probably the most fitting way for your own needs. So about Puppet modules, there have been discussions about data separation of course, who are Taylor talking about it and talking about here. How you separate the data you provide to configure your modules from the modules themselves. And how you can also provide this data outside of Puppet manifests. And one of the directions is also to use parameterized class, so to provide a sort of API, a sort of interface to module usage, in order to provide data without touching the modules. Also, one point is reusability. The Puppet Forge is supposed to be made to use and reuse modules, but this brings various problems because it's not easy to make a module that can be used in every situation for different purposes. And it's not easy to have a module that can be cherry-picked from a set of modules and placed inside your own infrastructure and make it work. As we have seen before, it's hard to just download a module from the Forge and use it. And it's not also so easy to be able to use a module without changing anything of the module, because otherwise it would not be reusable. Another point is the standardization of the code. There are good guidelines about styling style of the code, and there is the powerful Puppet lint command. I don't know if you know it. I suppose some of you know it. Which is useful to write a style with, let's say, Puppet code with a coherent style. Also, the same Puppet doc is useful to provide documentation about the module, but also somehow to standardize it. I mean, to provide documentation means also to have some kind of strict logic that can be understood by other people. Another point which is related to reusability is the interoperability of different modules. Many people do different modules. They can have overlapping resources. They can have dependencies. And to manage this kind of problem is not so easy. Actually, it will require a sort of agreement among the community people. But that's something that is not so easy. Another point, which is somehow obvious, is that since Puppet abstracts the operating system layer, also modules should be operating system neutral. And so, according to me, a good module should be able to be used in the same way, whatever the operating system behind, or at least whatever is the supported operating system. So, based on these, let's say, mantras, I tried to develop this kind of set of modules which provide various features. One of them is this coherent and standard structure. It's standard internally, I repeat. I mean, there are some design decisions in those modules which are not maybe approved by everybody, but at least the whole set is coherent in itself. And these modules try to follow the best practice about module designers, but at the same time try to introduce some features that may be particular, not opinionated somehow, but well, I felt like I wanted to do that. They support different operating systems, mostly Red Hat and Debian-based distributions, but they are made in a way to be easy to introduce new operating systems quite quickly and easily. And everything, every parameter, every configuration on those modules is exposed via a parameter. So you can use those modules as parameterized classes, but we will see we can use these modules also with other methods. And one of the main points was that I wanted to have them extremely customizable. You should be able to use really the module and customize it as you need without touching the module and without being forced on somehow a proposal on how, for example, you have to configure things. I don't want to enforce the way people should configure their own files, if they have to use templates, static files, or whatever. That should be an option available if someone wants to use configurations to manage configuration files in their own way. They should be able to do that with these modules. Another point is that it's somehow sometimes overlooked, is how you remove the resources that you introduce with Puppet. You know, when you include a class, and this class installs something on your system, it's not enough to remove the class you have included to remove the resources that this class had installed. So all these modules have somehow options to explicitly remove all the resources installed by these by the module itself. Then there is this monitoring abstraction, firewalling management. They are all options which can be enabled or not according to if you want to use them. There is this support for Puppy integration. Puppy is a module I wrote which has two main usages. One is to manage applications deployments, and the other one is to somehow what I like to call bring Puppet knowledge to the CLI. So provide a command line that can be used to run commands whose output can go somewhere else, wherever you want, to an inventory, central system, whatever. And these commands provide information about the resources deployed by Puppet. And all the modules have Puppet doc documentation, have been tested with Puppet lint, have RSpec tests, and they have based on a sort of standard structure in order to be possible to create a new module from scratch very easily with just a command line, and then from there configure and customize your module. The result of all this is that modules are actually quite complicated, so they are not easy to understand if you are not if you are new to Puppet. So this is a sort of trade-off. So let's get into these options we have about the modules. Basic usage is just you include the module, the class provided by the module, and you provide a normal installation of the relevant application, which is generally speaking for a typical package service configuration file application is you install the package, you start the service, and you don't touch the configuration file. So this is just the basic usage. For all the options that we can provide, to all the parameters we can provide to the modules, you can actually use different methods on how you provide the data. You can provide data as a parameterized class, so you just explicitly define the parameter you want to have, and that is the parameter used. But you can also use top scope variables, or the variables you can obtain from an external classifier, or you can use here. All these three main approaches to data input, so to say, are interoperable. You can set, for example, as in this example at the end, general top scope variable that affects all the modules, and then for specific modules have specific parameters. And this could be useful also for, let's say, it's another way to avoid a choice on how you provide the data. I mean, since my opinion is that I want to make modules that should be reusable and usable by as much people as possible, I don't want to enforce a way to provide data. You have here, you can use here. You have an external classifier, you can use an external classifier. You want to use parameterized class, you can use them. So let's see some of the parameters you can use with these modules and the effects on the modules. These are, let's say, common to all the module set. We talk about decommissioning. There are some options to manage the removal of the resources provided by the module. This absent true. You can also set disable true to, let's say, just stop the service provided by the module and disable it at boot time. And there is this option, disable boot, which is actually is not a perfect choice in the name, at least in naming, which just doesn't start the service at boot time, but doesn't check if the service is running. This is a typical case when you, for example, have a cluster managing the service. You don't want to Puppet manage the service by itself. But at the same time, you may want to, for example, monitoring it. So the point is, all these are available options, And one of the things that they do, besides managing the resources provided by the module, is that they also manage the monitoring of these resources. We will see inside the module there are options to monitoring the resources provided by the module, and the commissioning parameters like these also affect the monitoring part. Some other common options. You can sometimes have the need to see what Puppet will do on your system without actually making changes to it. So typically you can use a no-hope option with Puppet. But also there is this audit meta parameter, which is available for all resources, which can be used to auditing the changes that Puppet will do. So with the option audit only set to true, actually you enable it. You don't change files, for example, but you enable the audit meta parameter. Also, at times, you don't want to automatically restart a service when a configuration file changes. Most of the times you do it because you want that your changes are automatically implemented, but sometimes you may not want to do it. And so there is this option, service auto restart, which can be set to false to avoid the auto restart of a service when you change a configuration file. You can also provide the version of the package you want to install, so explicitly define a specific version or define latest to force Puppet to run to check if the package to be installed is set to latest. Now, about configuration and customization of the configuration. There are different options available to manage how you can configure your configuration files. First of all, as you know, typically a configuration file in Puppet can be provided as a static file provided by the source parameter or as an ERB template provided by the content parameter. So you can use either one of them as an alternative, and you can actually provide either the source parameter or the template parameter to set your custom file to use for to manage the main configuration file of your module. So you can use a single source statement with a single file. You can use a source statement with an array of files, which is looked in a lookup order. So the first match is the one you get. So for example, you can have a specific file for a specific node, host name for SSD, and then a default which is applied to every node. Or you can use a nearby template. Of course, source parameter and template parameter are alternative. You can use either one or the other. And they both work on a file, which is generally configured automatically, which can be, whose path can be changed with the config file parameter. Now, when you use a template, you can also provide a sort of custom options parameter. This options parameter can be an hash of values. And you can use these values inside your own template. So in this way, you can provide whatever kind of parameter to the class without changing the class, and to configure your specific configuration file. Now, this is not exactly the best pattern around. I mean, there are some trade-offs to consider when you have to provide an options parameter like this. Here you can see some ways you can use these options in your template, your ERB template. As you see, there are some things to consider. You can directly use the option parameter, like in the first case. But for example, if you don't provide that options use PAM, you have there an empty space, and this will probably break your configuration. So you could try to make some kind of fail-safe check if there is an options use PAM parameter set passed, then you use it. Otherwise, you use a default one. But as you see, this is not something exactly. It's a bit verbose to say to use for each parameter in your template. And at the same time, as another alternative, you can also have a sort of okay, all the options parameters I have in my hash are used in my configuration. This can apply, this is the third case, this can apply when you can have configuration files. We can be totally blank because there are settings can be by default already set, and you can add whatever in whatever order, whatever options you may want. So this is an option. When you use templates, you can also provide an option parameter to configure the specific configuration items you may want in your configuration file. Also, sometimes you may want to configure a whole configuration directory. Sometimes you may need to say, oh, there is not just the main configuration file. There are other files in that directory. So you can provide the source dir parameter to set a source dir or an array of source dirs on the Puppet master to use as a source to populate the destination dir on the local nodes. There is an option, which is very dangerous, which is a source dirs purge, which actually is a sort of, it purges the local files if they are not present on the Puppet master. This can be used when you want to be sure that the content of a configuration directory is exactly as you want, so they are not external files not managed by Puppet. But of course, if you don't provide all the files you need on your Puppet master, you will delete files on the destination nodes. Also, this is an option. You can use it if you want or not. Another point is that actually you don't always need just to modify the configuration files. Many times you may need to add the resources to your modules. Maybe you want your Apache with a document root somewhere else, you want to create that directory, and you want to add specific files and so on. So there is this my class option which allows you to provide the path of a custom class which can be used to insert whatever resources you may want related to the module. The point is that, well, the path is in typical, let's say, Puppet autoloading syntax, so name of the module / name of the class. It's important not to use the same name of the main class in your custom class because you may have some naming clashes. You may have your custom classes loaded before the main class, and bad things can happen. And you may need to have an inheritance of your custom class to the main class, but actually, and this can provide some problems in sometimes, but actually, since practically everything of the main class in the module is customizable, you rarely have the need to change something, some parameter of resources provided by the class, which is the only case when you actually need to use an inheritance model with a class. Also, you can have at your disposal many parameters to manage every single configuration item you have in the module. So, for example, what's the package name, the service name, the path of the configuration file, some parameters that affect the monitoring stuff, and so on. Whatever is used internally by a module to configure Puppet for different operating systems can also be provided as an option. Of course, all these parameters are generally managed automatically according to operating system you use. But you may need to have customization. So, for example, you have your own package of an application. You may want to provide custom parameters, paths, names, and so on for your package. This is an extreme case, according to me, because you can use, for example, use Puppet to manage Puppet Enterprise, which has totally different path names, names of the package, and so on. But you can. And just using the Puppet module. So this is something that is not so common, in my opinion. Now, to now we have seen options you can use to customize the behavior of the module. Then there are some other options you can use, and they are optional, and by default they are disabled, to customize and to define for example, monitoring abstraction. What I mean, if you set monitor to true, and as we have seen, you can set this as a parameter, you can set this as a top scope variable or an HERA. Then you enable the monitoring part. This just basically introduces a new define, which receives as input all the parameters the Puppet module has about configuration parts, ports, and whatever. And you can define also the tool you may want to use to monitoring this module. These tools are, you don't need to, let's say the integration of different monitoring tools with Puppet is done in a specific module, which is called monitor module in the example 42 set. And there you just have a define to add or change to create a new integration with a new monitoring tool. The funny thing is that you can use, for example, a Nagios module for somewhere else, a third-party Nagios module, configuring the correct plugin for that module, and you have that module used inside to monitoring the example 42 modules. So the point is to really abstract and leave the freedom to choose the monitoring stuff you might want to use according to your needs. The good thing is that you just need to add a new monitor tool there, and monitoring is supposed to automatically be done for all the modules you have installed in your system with the tool. You can specify which target, which IP view to use for monitoring. Actually, it can be also a fully qualified domain name or the IP address of a Ethernet 1 interface or whatever. It can be also localhost for some cases. And all the options that affect the monitoring are the ones written below. Port and protocol to monitoring if present listening port, and then the service, the process speed, and something like that. A similar thing is done for the firewalling abstraction. You can set firewall to true. You can use firewall tool EP tables. EP tables is the only actually existing firewall tool available at the moment, and is a module used to manage host-based firewalling. So it's not a networking firewall. And you can set the destination and the source addresses to configure in a more granular way how you want to manage the firewalling for that, the resources provided by the module. Actually, what you see here is that this opens a port, creates a rule that allows traffic to the relevant port. Another way of integration is this, the possibility to enable the PuppI integration. Well, PuppI is a module that is required by all the example 42 classes because it provides some functions that are used by all the modules. But you can just have Puppet in your module set, but you are not forced to use PuppI integration. If you want to use it, enable it, you have just to set PuppI to true. And in this way, you can have commands like PuppI log OpenSSH, PuppI info OpenSSH, Puppet check OpenSSH, which provide information about that service, show you the log of your service, and so on. This is not something that every good system administrator can provide by hand. You just use custom common commands. But the point is that these are standard commands you can have for all your modules, whose output can go wherever you want. So it can populate a CMDB or whatever. And which can be useful to have a quick access to information on your system from the command line. Now, we have talked at the beginning about the fact that we can provide data to the module in different ways. How this is done? This is done by a function which is called params lookup, which is provided by the PuppI module. This params lookup function is used for all the parameters of the module, and actually we will see later how it works. Generally speaking, just it accepts the name of the parameter to look for, and optionally a global parameter we will see later. we will see that, you are seeing that, as you can imagine, all these classes have a huge amount of parameters. They can be too much, maybe, but the point is that with these parameters, you can configure every aspect of the module. Generally speaking, these parameters can be divided in different families. There can be module-specific parameters, something that are related just to that module because you have some customization specific for the module. Parameters that affect the customization of configuration files or the possibility to customize your own, to provide your own custom class. Parameters that affect the behavior of the module, whatever we have seen for decommissioning, auditing, and something like that. Parameters that manage the extensions, such as monitoring, firewalling, and Puppy. And the parameters that just define the paths and the names used by the module. So all these parameters are parsed by this params lookup function, and this params lookup function, another point. All these parameters have a default. You can use the class, as you have seen, without providing any parameters. The defaults are set in the params pp class inside the module. So here, there are managed all the operating system differences between for different options. And their defaults are set at same defaults for example, monitoring, firewalling, and so on. So as you've seen, I told you monitoring by default is disabled, and this is because in the params pp there is monitoring set to false. So we are saying all the parameters pass through the params lookup class. This is a function. This is a function that looks up for the value possible. Possible values in different places according to different orders. So first of all, if you provide directly the parameter as a parameter to the parameterized class, that's the default Puppet behavior, that's the parameter used. If not, there is first a lookup on here. If here is available, then there is a here lookup. And if you set the global option, here lookup is done directly on the name of the parameter. So for example, there is monitor set to true in here, and there is the global option set for the monitor parameter. Then there is a lookup for the monitor parameter. If there is not this global option set, then the lookup is done on the module, a parameter called with the module name underscore monitor. So the point is that there are some parameters that can be used globally, some which have no sense to be used globally. For example, the configuration path, the path of a configuration file is not a global parameter. It changes according to every module. That's why there is this difference. At the same time, if here is not available, then a lookup is done for the top scope of variables. And this is done with the same logic. If there is a global option set, then a lookup is done for the name of the parameter. If not, a lookup is done for the name of the module underscore the name of the parameter. So this should allow both data separation using different logics, and overwriting of common functions and more specific functions according to your own modules. All this stuff is available online. There is a GitHub repository. Actually, there are many repositories. There is a Puppet modules repository, which is, let's say, the historical and main repository, which holds both new and old modules. Then there is the Puppet modules next gen repository, which just contains the new next generation modules. And all the single modules are defined as a single Git repositories. So basically, the Puppet modules next gen, for example, is just a simple repository with many Git submodules. Everything can be commented, used, and you can, all pull requests are welcomed online. Now, I want to show you one thing. I said at the beginning that we can have complete decommissioning of modules, complete we can have scaffolding of modules. There is a command available in the Git repository, which is module clone. You can use it to clone a module from scratch based on a template, existing template. There are various templates of modules for different kinds of modules. For example, there is the foo template for the typical package service configuration file module. There is a sort of foo web app template for a module more related to the installation of a web application, where, for example, you don't have the need to manage a service or something like that. And you just can, I can share you maybe by directly. You just can, I have in the directory just as created by the Git repository. In the example 42 tools, there is this option, this script, very simple, module clone. By default, it takes as a template the module called foo, but you can specify a specific module template. You enter the name of the module you want to create. So, for example, WSFTPV. It creates a WSFTPV module. Of course, there's just some said to change the names, which can be customized. So we get inside. You have the documentation, module file, rec file with the tests. In manifests, we have the params pp class. Basically, for a typical package service configuration file module, you just need to change something here. Most of the times, you don't need to change anything, but if you need to specify different names for different operating systems for these parameters, you just can add them here. And once you have done this, actually you have your WSFTP module ready with all the features we have seen up to now. But of course, most of the times you may need to change other resources because the application is not just a configuration file and maybe needs some custom defines to manage configuration parts somewhere else and something like that. Well, that's something that you can do directly in the main class or in classes you can include from there. This I will show you just quickly how this a typical module is set. You have all the documentation, which is quite long, in Puppet doc format. Then there is the class itself with all the options, the parameters, and the params lookup for these parameters. As you've seen, for example, service auto restart can be set at global level. I never wanted to set auto restart of services when I change configuration file. You can set it either per module or for every module and override it where needed. Then there is the, well, after all these parameters, there is the inheritance of the params pp class where the defaults are set. There are some variables used to sanitize somehow all the possible Boolean values. So actually you can set monitor true, monitor yes, monitor true among quotes, and everything is sanitized, converted to a real Boolean. Then there are some other internal variables used to manage all these abstraction layers. So for example, according to the service should be enabled, well, it depends. If disable boot is set to true, then you don't have to enable it. But if by default, you have then to see if other parameters are set. So these are all used internally to manage actually all the configuration of possibilities. And after this set of variables that you should generally not change them, you have the real resources managed by the module. And as you see, practically all of them have parameters set, variables set, which are somehow calculated or provided directly by the user. Package, service, file. So actually, for example, if you need to add a new file to configure other parts of the module, you can also copy and paste existing file, change, for example, some parameters. You may need to differentiate the source, the content, something like that, and then have it. And it will inherit all the properties of the main configuration file. So, for example, if you set to disable, to remove, to absent the if you provide the absent parameter, you remove also the added file you may create. And then there is the inclusion of custom class, and if provided, the inclusion of Puppy integration, monitoring stuff. As you see, when I define what to monitor, I define something like this: port, protocol port, target, tool, process. And then in this module, which is one of the modules of the example 42 set, you have the, let's say, connectors to different tools. And that's more or less the main content. As you see, there are not many resources. I tried also to shrink the number of resources. I didn't want to have too many classes, subclasses, and so on, as I used in the past, because I've seen that more resources you have, more classes you have, and more time the master takes to compile the catalog. So I tried also to optimize somehow the code in order to be as fast as possible. I was concerned by the usage of this params lookup function for each parameter of each class, but actually it doesn't seem to affect too much the speed of the compilation, so that's okay. And well, that's just an example. Of course, from here you can customize other things to the module, but all the basic resources and all the basic functions you have and we have seen up to now are available. Okay, that's all. If you have questions, I'm here to answer.
One question. If you don't want to actually have the class manager, for example, the OpenSSH, SSHD config, because you want to manage the configuration without this, for example, can you do that?
Well, by default, if you don't provide parameters related to a configuration file, you don't change the configuration file.
How can you repeat the question? Sorry.
Pardon. He asked if you don't want to manage directly a configuration file, for example, the configuration file of OpenSSH, because you may want to manage it with Augers or in other ways, how you do it. And the behavior, the default behavior of the module is that configuration files are not managed, are not changed. Actually, they are managed. You have ensure present and the, let's say, the mode, the owner, and so on. But the content is not touched by default. In the previous modules, actually, I had also a define to make inline configurations for each possible parameter in a configuration file. So it could be it was possible to manage a configuration file as with Augers or other tools with line by line. I removed it because actually I think that it can be really heavy to manage every configuration of a file, because every line should be a resource, so it can grow quite a lot. But actually, it's an option you have. I mean, you can have your custom class that manage the configuration file. Maybe I should re-add this option to provide by default a conf defined that creates a line of configuration inside the module. But anyway, you don't need to do anything by default to change it.
I'm sorry, I'm not a Puppet expert. I know nothing about it. But could you imagine that the OpenSSH developer would provide as yum install OpenSSH-Puppet module?
Well, he asked if it would be possible that the same developers of OpenSSH could provide a module to manage OpenSSH. Well, this is an option which is possible for everybody. Up to now, it's not happening, as far as I know. But at the same time, you should consider that, for example, you should provide a module which adapts to different operating systems. And this is a work that maybe should be done more by the providers of the distribution than the providers of the application, the coders of the application. But it depends. For the moment, generally speaking, it's hard to see Puppet modules provided directly by who creates the applications. And, but that's an option. And it will be, let's say, another module of the many available to manage that application. Other questions? OK, thank you very much. Have a good day.
Let's take a quick break until 11:05, and then we'll meet back in here for the next talk at 11:05. And we're running a little bit behind, so please take time if you can.
You gave me a great link to my talk. I'm going to talk about SSHD. Oh. Okay, no, hold on a second. This is not going to be very practical.
How you doing?
Fine.
Got everything you need?
I think so. Should be fine.
Okay, well, I told them we'd start at 11:05, so hopefully people are back in time. We're supposed to have a 20-minute break, so I want to make sure that everyone got a little time to stretch their legs. Cool.